You guys must have paid attention to the fact that we utilize nichrome heating wire for almost everything. These are quite amazing. They have very high resistance and they can handle very high temperature. They can easily go up to 1000 or even 2000 degrees Celsius. However, you have to understand this part. When we want to basically room heat, we're gonna dump, let's just say, 3 kilowatt of energy. However, the wire, because it's surrounded by air and it has a lot of spacing, air can easily take heat away. And benefit of that would be the wire temperature itself will not be very hot, as in 100 to 200 degrees Celsius surface temperature. However, the fact that it is a naked conductor is the biggest problem. If you dunk it into water, it will just cause a short circuit and kaput your fridge and fuses. So for that reason, we generally have to cover it with some insulator. Now we are talking about high temperature. Nichrome can go ludicrously high temperature, so you have to have an insulator that can handle it. Only thing that can handle it, not silicon, it's ceramic based systems. And then there causes a problem that if you have water, it will dissolve in ceramic at high temperature. So we have to encase it in stainless steel or something like, nickel steel or something like that, in order to make sure that it does not basically dissolve, quote unquote. And doing that, we get nichrome wire inside the insulator, and then insulator is encased into a steel pipe. But there's the problem. It's like, how the heck you going to conduct heat if you are covering everything with insulator? This is the critical part. The nichrome wire runs even hotter. Like in your air heater scenario, it would be running at, let's say, 100 to 200 degrees Celsius. In a water heater element, it could easily be 400 to 600 degrees Celsius, or maybe even hotter. And this is why they always come with a warning: do not run them dry, because if you do so, air cannot leach enough heat away, in contrast to water, that it will create a scenario where the nichrome wire is getting hotter and hotter, because again, the outside surface is not cooling down, so heat is not flowing. It will go to 2000 degrees Celsius and melt and basically short out. So for this reason, you have to basically make sure that insulation is as thin as possible when you are making that sort of wire, and you have something that can leach heat away effectively. Failure to do so, you will short your basically heating element. And again, the primary reason of water heater element failure is generally that water hardness, and it causes basically almost an insulation layer on top of your heating element, like sort of calcite kind of structure. Now the easiest way to safeguard against that is open your heating element once in a year, dunk it in vinegar. That will clean out the stainless steel tubes, and voila, it will run for years and years. But failure to do so, because you are adding in extra insulation, now it could be behaving like, even though the watt element is same energy as in 3 kilowatt, it could be going as high as 800 or 900. It will shorten its lifespan exponentially. So be very mindful of this data point.